We're going to go through an energy transfer example. And so to explain to you our system here, we have some water, 10 kilograms of water. The water's temperature is 20 degrees Celsius. We are going to put a piece of steel inside of that water. The steel's mass is 5 kilograms and its temperature is 60 degrees Celsius. And so what we're going to do is when we put the steel into the water, the energy is going to transfer from the steel into the water. We're going to figure out what the final temperature of both the steel and the water is when they reach equilibrium. A couple other things we need to know is heat capacity of both materials. So the heat capacity of water is 4,184 joules per kilogram degrees Celsius, and the heat capacity of steel is 500 joules per kilogram degrees Celsius. All right, if we look at our formula sheet, we can look under the thermodynamics part, and we can look at our thermal energy equation. It's right here. Q equals the area of the thermoconductivity times the coefficient of heat conductivity times the change in temperature. And we will use a version of that equation for our calculation. And so we are going to say that the energy transfer is equal to the mass times the heat capacity of the material times the change in temperature. And so we're trying to figure out the change in temperature, and so we need to set each of these things equal to each other. And so on one side we'll have the steel, and on the other side we'll have the water. So our calculation will go the mass of the steel times the heat capacity of steel times the change in temperature is equal to the mass of the water times the heat capacity of the water times the change in temperature. All right. The next step is to substitute in. So on the steel side, our mass of steel is 5 kilograms. Heat capacity of steel, 500 joules per kilogram degrees Celsius, times the change in temperature. So the temperature starts out at 60 degrees Celsius, and we don't know what the final temperature is. So we'll label that as TF. That has to be equal to the mass of the water, which is 10 kilograms, times the heat capacity of water, which is 4,184 joules per kilogram degrees Celsius, times the change in temperature of the water. So the final temperature minus the 20 degrees. Okay. Now we can simplify our formula. 5 times 500, 2,500 times 60 minus the final temperature is equal to 41,840 times the final temperature minus 20. We then distribute, so 2,500 times 60, 150,000. Minus 2,500 TF is equal to 41,840 TF minus 836,800. add a 2500 TF to get the variables on the other same side. We have 150,000. We add 2500 TF to this, and we get 44,340 TF minus the 836,800. Add 836,000 to the other side, and we get 986,800 equals 44,340 TF. Divide to get TF by itself, and we get a final temperature of 22.25 degrees Celsius, and that equals our final temperature. So there's an energy transfer example, and we can determine the final temperature once equilibrium has been reached through our two materials.